Here we are at IncideFocus in the electronics room.
Right. And so this is an example of one of the boards. This was actually designed to control our greenhouse. And so it has power drivers for water pumps and air fans, that kind of thing. It has Arduino compatible microcontroller on it. And it has some input circuitry which uses things like step response circuits. So for example, here's a water level sensor for the aquaponics system. This was acrylic that was laser cut, copper foil that was vinyl cut, and then a piece of vinyl on the inside that's red. If you put the two of them together, you get a capacitor whose capacitance varies depending upon the dielectric inside. And so it can measure the air-water balance percentage. So this is a non-cloggable water level filter. If you went to Granger to buy one of these, you'd spend $30. This is about $2 worth of material. And so this circuit basically puts a step on it and looks at the decay of the RC circuit, which is determined by the capacitance of this. So you can build the electronics, and then you can kind of understand that the more you understand about the physics of these things, the less expensive it actually is to build things. And so it gives the folks a lot of incentive that math stuff and physics stuff, you know, actually might be kind of useful because I can build useful things with it. So we actually work on building a lot of sensors. With the vinyl cutter, you can make sets of vinyl fingers that if you put a elastomeric material in between and you change the pressure, change the electrical relationship between the two and the AC circuit, and then you can build little microcontroller driven circuits that can measure that. So you can do force sensors and all sorts of things like that. So we have 8, 16, 32-bit microcontrollers in stock, all sorts of normal, passive, and active components, little sensor units from 6-axis, accelerometers, GPS items, microphones, etc. So a lot of input circuits, output circuits, standard kind of test equipment. We have, you know, bench power supplies, signal generators, oscilloscopes, and then we teach folks how to actually hand solder the surface mount boards, and we can also do solder reflow in a little toaster oven that we have in the process also. So we put on a copper paste, silk screen it on, and then do the reflow in the toaster oven. Usually it's much faster to just solder it by hand unless you're going to do a number of boards.
And again, all this furniture was cut in prototype on the laser jet cutter from the cardboard boxes the bench came in, and then cut on the ShopBot then from plywood, and no fasteners, all press fit with a rubber mallet so that they can be disassembled and reassembled at any time. And that's true for the entire shop.